Before we start, let me know your space video ideas in the comments below. And don't forget to like, subscribe, and turn on the notification bell so you never miss a cosmic adventure like this one. What if, right now, without warning, the Earth began falling into a black hole? Imagine looking up at the sky and seeing a patch of darkness where the stars bend and swirl, where light itself curves like water down a drain. Within seconds, the familiar blue of our planet would be on a one-way journey toward the most extreme object in the universe. Today, we are exploring exactly what would happen if Earth were pulled into a black hole. First, we need to understand what a black hole actually is. A black hole forms when a massive star collapses under its own gravity at the end of its life cycle. The core compresses into an incredibly dense point known as a singularity, surrounded by a boundary called the event horizon. The event horizon is the point of no return. Once anything crosses it, not even light can escape. Some black holes are only a few times more massive than our Sun, like those created after supernova explosions. Others are supermassive monsters sitting at the centers of galaxies, including the one at the center of the Milky Way called Sagittarius A. For this scenario, let's imagine a rogue stellar mass black hole, maybe 10 times the mass of our Sun, wandering through space. It doesn't glow, it doesn't shine. It's practically invisible against the darkness, detectable only by how it bends light and affects nearby objects through gravity. If one of these cosmic predators drifted too close to our solar system, the first signs would be subtle but terrifying. Long before Earth itself was directly pulled in, the orbits of the outer planets would begin to shift. Neptune and Uranus might wobble. Comets in the Oort cloud would scatter in strange new directions. Astronomers on Earth would notice something disturbing. The stars in one region of the sky would appear distorted, stretched into arcs by gravitational lensing. That bending of light would be our first visual clue that something massive and invisible was approaching. As the black hole moved closer, its gravitational pull would begin to compete with the gravity of our Sun. Earth's orbit would destabilize. Instead of tracing a predictable ellipse around our star, our planet would start to drift. Days and seasons would become chaotic. The length of a year would change. Tides would grow stronger as gravitational forces tugged at our oceans from an entirely new direction. If the black hole passed close enough, Earth could be captured entirely, ripped away from the Sun's gravitational embrace and placed into orbit around the black hole. At first, this might not look dramatic from the surface. The sky would darken as the Sun grew smaller and more distant. Temperatures would begin to drop. Within weeks, global climates would collapse. Plants would struggle without sunlight. Photosynthesis would slow, then stop. Food chains would begin to unravel. But the real horror begins as Earth spirals inward. As we draw closer to the black hole, tidal forces become extreme. Tidal force is the difference in gravitational pull between one side of an object and the other. On Earth, the Moon creates tides in our oceans because its gravity pulls slightly harder on the near side of the planet than the far side. A black hole, however, magnifies this effect to unimaginable levels. The side of Earth facing the black hole would feel a much stronger pull than the opposite side. At first, this would mean massive earthquakes as tectonic plates strain under uneven forces. Volcanoes would erupt worldwide. The crust would crack as if squeezed in a cosmic vice. Oceans would slosh violently, forming megatsunamis thousands of meters high. Cities along coastlines would vanish beneath walls of water. As Earth gets even closer, the tidal forces would stretch the entire planet. This process has a dramatic name: spaghettification. Objects falling into a black hole are stretched vertically and compressed horizontally, like spaghetti being pulled apart. For a human being, this would be fatal long before reaching the event horizon. Your feet would feel a stronger gravitational pull than your head, stretching your body until it literally tears apart at the atomic level. For a planet, the same principle applies on a grand scale. Mountains would crumble, the mantle would deform. Eventually, the structural integrity of Earth would fail. Our once spherical world would elongate into an oval, then a teardrop shape. The oceans and atmosphere would be stripped away first, forming a glowing stream of debris spiraling into darkness. As Earth approaches the event horizon, something strange happens to time itself. According to Einstein's theory of general relativity, gravity warps space-time. The stronger the gravity, the slower time moves relative to an outside observer. If someone were watching from a safe distance, they would see Earth slow down as it neared the event horizon. Our planet would appear to freeze in place, its image gradually reddening and fading as light struggles to escape the intense gravitational field. From our perspective on Earth, however, time would feel normal. We would not notice any dramatic slowing. Instead, we would continue falling inward, crossing the event horizon without experiencing a visible boundary. There is no solid surface marking the edge, no wall, no signpost, just a point in space beyond which escape is impossible. Inside the event horizon, all paths lead to the singularity. The laws of physics, as we understand them, begin to break down. The singularity is thought to be a point of infinite density where space-time curvature becomes infinite. Whether it truly is infinite, or whether quantum gravity effects change the picture, is still one of the greatest mysteries in modern physics. As Earth descends further, it would be completely torn apart. The planet would no longer exist as a coherent object. Instead, its matter would form an accretion stream, superheated by friction and gravitational energy. This material would emit intense radiation before finally being swallowed. To an outside observer, the black hole might briefly flare brighter as it consumes the mass of an entire world. But what if the black hole were supermassive instead? The experience would be surprisingly different. Supermassive black holes, like Sagittarius A, at the center of the Milky Way, have much larger event horizons. The tidal forces at the boundary of a supermassive black hole can actually be weaker than those near a smaller one. In theory, you could cross the event horizon of a supermassive black hole without immediately being torn apart. You would not survive for long, but the initial crossing might feel uneventful. If Earth were pulled into a supermassive black hole, the destruction would begin later in the fall. The planet might remain intact as it crossed the event horizon, only to be crushed and stretched deeper inside, where tidal forces grow stronger. From the outside universe, however, the result would look similar. Earth would fade, slow, and eventually disappear. There is another mind-bending possibility. Some theoretical models suggest that black holes might be connected to other regions of spacetime through wormholes. These are hypothetical tunnels predicted by solutions to Einstein's equations. Could Earth emerge somewhere else in the universe? Could falling into a black hole be a doorway rather than an end? Most physicists believe this is extremely unlikely. Wormholes, if they exist, would probably be unstable and collapse instantly. The intense gravitational forces inside a black hole would almost certainly destroy any structure before it could pass through. Still, the idea captures the imagination. A planet vanishing from one galaxy only to appear in another is the stuff of science fiction, but it is rooted in real mathematical possibilities. Now consider the broader cosmic consequences. Removing Earth from the solar system would slightly change the gravitational balance. The Moon would drift without its partner. It might eventually be captured by the Sun or flung into deep space. The other planets would continue orbiting largely unaffected unless the black hole disrupted them as well. The Sun itself would remain intact unless it too ventured too close. The energy released as Earth's mass spiraled into the black hole would be enormous. Matter falling into a black hole converts gravitational potential energy into radiation with incredible efficiency. In some cases, this process powers quasars, the brightest objects in the universe. Our planet's destruction might produce a brief but intense burst of X-rays and gamma rays, a final cosmic scream announcing its demise. And what about humanity? Long before the final plunge, civilization would collapse under environmental chaos. Freezing temperatures after losing the Sun would force survivors underground. Geothermal and nuclear energy might sustain small populations temporarily. But as tidal forces intensified and the planet began to physically deform, survival would become impossible. The very ground beneath us would betray us. There is a strange comfort, however, in understanding the scale of the universe. Black holes are terrifying, but they are also incredibly far away. The nearest known black hole is thousands of light years from Earth. The odds of a rogue black hole wandering into our solar system anytime soon are extraordinarily low. Space is vast beyond comprehension. Even galaxies rarely collide directly. They pass through each other with most stars never touching. Still, imagining these scenarios teaches us about physics at its most extreme. It forces us to confront the fragility of our planet and the power of gravity. It reminds us that Earth is not the center of anything cosmic, but a small, delicate world orbiting an ordinary star in an ordinary galaxy. If you could somehow watch from a distant spacecraft as Earth fell into a black hole, the sight would be both beautiful and horrifying. The planet would glow red from gravitational heating. Its shape would stretch into a luminous ribbon. The surrounding stars would appear warped into circles of light known as Einstein rings. Then, slowly, inevitably, Earth would dim, freeze, and vanish. No explosion, no dramatic bang echoing across the cosmos. Just silence. And yet, even in that silence, the story would not truly end. The atoms that once formed oceans, mountains, forests, and cities would still exist, compressed and transformed within the black hole's mass. Information may not be destroyed after all. Modern theory suggests that information about what falls into a black hole might be encoded on its event horizon, a concept known as the holographic principle. The debate over whether information is lost in black holes remains one of the most profound questions in theoretical physics. So what would it feel like in the final moments? As the sky darkened and the stars twisted into spirals, there might be a surreal beauty to it, the universe revealing one of its deepest secrets in the most personal way possible. But the physical reality would be merciless. Gravity would stretch, tear, and ultimately erase every structure we have ever built. The idea of Earth falling into a black hole is terrifying, but it is also a reminder of how finely balanced our existence is. We orbit at just the right distance from the Sun. Our star is stable. Our galaxy is relatively calm. Catastrophic cosmic events are possible, but they are rare on human timescales, and perhaps that is the most powerful takeaway. The universe is violent and extreme, yet here we are, alive on a small blue world, able to imagine its destruction and understand the physics behind it. What would you do if you knew Earth had only months before being pulled into a black hole? And what space scenario should we explore next? Let me know in the comments below. If you enjoyed this deep dive into cosmic catastrophe, make sure to like the video, subscribe to the channel, and turn on the notification bell so you don't miss the next journey into the unknown. Thanks for watching, and see you in the next one.